I think the very first problem is very clear to you. Now I'll be going in a little better depth of this particular integral problem. Now we try to solve this particular problem. I think it's an example problem. Integral of x power 4 plus 5x square plus 3 by root x dx. If you could observe carefully here, A, I will consider this as B, I consider this as C, and I consider this as D. So in our lower classes, in ratio and proportion, we learned a concept. If A plus B plus C by D is given, means it can be written as A by D plus B by D plus C by D. The same technique we will be applying over here. So how it comes means x power 4 by root x dx plus 5x square by root x dx plus 3 by root x dx. Finally, if you could observe carefully, I think I can apply total integration now. Why? Because algebraic properties, I think you are clear. X power 4 by root x dx, 5x square by root x dx, 3 by root x dx, I can apply integrals individually because of the algebraic properties of integrals. Now before applying the integral, if you could observe carefully, it is looking like x power m by x power n. Here m की जगह में 4 और n की जगह में 1 by 2. So finally what I will be doing means x power 4 minus 1 by 2, x power 4 minus 1 by 2 dx. Why? Because x power m by x power n means x power m minus n. And now here also 5 I will be taking outside. Finally what happens? X square x power 2 minus 1 by 2 dx. I think it is clear to you because it is like x power m by x power n. So x power m minus n plus again here 3 will be coming outside, and here what happens? X power minus 1 by 2 dx. Now if you could observe carefully, this is looking like x power 7 by 2 because 4 minus 1 by 2 LCM. I need not explain all these basics now. So 5 into here also x power 3 by 2 dx, and here 3 into integral of x power minus 1 by 2 dx. And now again our basic formula comes, it is like x power n dx. X power n dx means x power n plus 1 by n plus 1. So x power 7 by 2 plus 1 by 7 by 2 plus 1 plus 5 into x power 3 by 2 plus 1 by 3 by 2, 3 by 2 plus 1 plus 3 into, here again it goes as x power minus 1 by 2 plus 1 by minus 1 by 2 plus 1 plus c. I think now you can do this particular calculation, and I will be writing there the answer finally. X power 7 by 2 plus 1, 7 by 2 plus 1 means it is 9 by 2, and denominator also 9 by 2, going up means 2 by 9. So what happens? 2 by 9 x power 9 by 2 plus, again if you could observe carefully, here 5 is there and here 3 by 2 plus 1, 3 by 2 plus 1 means 5 by 2. So what happens? 5 into 2 by 5, and here x power 5 by 2. Finally here also 3 is there, and minus 1 by 2 plus 1 means half. So what happens? 3 into half going up means it turns down to 2, and here x power 1 by 2. Finally I will write here plus c. So finally we will be manipulating and telling the answer. 5 will be getting cancelled here. So 2 by 9 x power 9 by 2 plus 2 into x power 5 by 2 plus 6 x power 1 by 2 plus c. Up till now we had seen some problems based on application of integral in with respect to algebraic function. Now और थोड़ा level बढ़ जाएंगे, we will be doing application of trigonometric functions, and we need to remember the formulas. At the beginning of the class only I said the formulas, right? Now here there are two problems. The very first problem we'll be looking up, integral of sine cube x plus cos cube x divided by sine square x cos square x dx. Now again the same concept here, a plus b by c. So it comes as a by c plus b by c. So finally what happens, that is equal to, I'll be writing it as sine cube x divided by sine square x cos square x dx plus again integral of cos cube x divided by sine square x and cos square x dx. Now if you could observe carefully, here sine cube x is there and here sine square x is there. I think blindly I can cancel one sine square x and finally there remains here sine x. Now again if you could observe carefully, here also one cos square x and here cos square x gets cancelled, there remains cos x. So finally what happens, there remains integral of sin x by cos square x can be written as cos x, and another cos x I will be writing it as 1 by cos x dx. I think it is clear because cos x into cos x is cos square x. Similarly here also cos x divided by sin x and here again 1 by sin x dx. Now I think it is clear, sin x into sin x is sin square x. So finally it reduces to sin x by cos x is nothing but tan x and 1 by cos x is nothing but secant x dx, and here also cos x by sin x is nothing but cot x, 1 by sin x is nothing but cosecant x dx. So friends, now again we got our formula. We should remember the basic formula. Integral of secant x tan x is always secant x, and integral of cot x cosecant x is always nothing but minus cosecant x, finally plus c. So once again I will be repeating the problem. Integral of sin cube x plus cos cube x divided by sin square x cos square x. It is like a plus b by c. A plus b by c means a by c plus b by c. So what happened? Sin cube x divided by sin square x into cos square x. One sin square x is getting cancelled, so there remains sin x, and here also cos square x is getting cancelled, there remains cos x. So finally what happening, sin x by cos x into 1 by cos x dx plus cos x by sin x into 1 by sin x dx. Now sin x by cos x is nothing but tan x, 1 by cos x is nothing but secant x. Cos x by sin x is cot x, 1 by sin x is nothing but cosecant x. So integral of tan x secant x will be secant x, and integral of cot x cosecant x will be minus cosecant x plus c. Now I will be going for another problem. Integral of 1 minus sin x by cos square x dx. Very beautiful problem. It is also looking like a minus b by c, so I can make it as a by c minus b by c. So here what happens, integral of 1 by cos square x dx minus integral of sin x by cos square x is there, so cos square x I will be writing as 1 by cos x, can I write like this, sin x by cos x into 1 by cos x dx. So if you could observe carefully, 1 by cos square x is nothing but secant square x dx, it's a secant square x dx, minus here also sin x by cos x means what beta, tan x, and 1 by cos x is nothing but secant x dx. So again our formula is coming, integral of secant square x, integral of secant square is nothing but tan x, and integral of tan x secant is nothing but secant x plus c. So in today's class we learned about application of integral with respect to algebraic function and application of integral in trigonometric function. Right friends, in previous class we had seen some basic integration concepts and application of integration with respect to algebraic function and in trigonometric function. Now we shall go for a little bit higher level. There are various methods of doing integration. The very first one we call as a transformation, integration by transformation, and next number 2 substitution method, number 3 by parts, and number 4 partial fractions. Right, in today's class, we'll be seeing 2 to 3 examples based on this particular transformation. I'll be taking 2 to 3 problems and remaining problems I give as a worksheet.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.